Every single day, a mind-boggling number of messages fly across the globe. We're talking photos, business deals, private chats, just an entire world of digital conversation. So, how do we make sure it all stays private? Well, let's dive in and find out.
We send billions of these messages, and we do it with this quiet assumption that they're for our eyes only. From a simple, hey, to our most sensitive financial info, we just send it all out there, trusting it's going to arrive safely and, more importantly, secretly.
But what's really stopping someone from just plucking one of those messages right out of the air and reading it? What is this invisible shield that protects our digital lives as they travel across the huge public network of the internet? The answer is an incredible piece of technology called end-to-end encryption.
The easiest way to get your head around this is with a simple analogy. See, sending a regular, unencrypted message is a lot like sending a postcard. Anyone who touches it, the mail carrier, the folks at the sorting facility, they can read the whole thing. But encryption? That's like putting your message inside a steel box, snapping a heavy lock on it, and then sending it. Anyone can handle the box, but only the person with the one specific key can ever open it up and see what's inside.
So this idea of a digital locked box is really the heart of what we're talking about today. But here's the thing, not all locks are created equal. So let's look at the specific promise of end-to-end encryption, or E2E, and why it is such a game changer for privacy.
You've probably seen that little padlock symbol in your web browser, right? Well, that's encryption, but it's usually something called encryption in transit. What this means is your message is locked between your device and, say, a company's server. But, and this is a big but, the company could unlock it on their server before they send it along. With true end-to-end encryption, that middle step just gets completely cut out. The message stays locked from the second it leaves your device until the very second it lands on the recipients.
And this is the absolute crucial point. With true E2E, the company running the messaging service is totally blind to your content. They basically become a delivery service for locked boxes that they can never, ever open. They can't read your messages, not even if they wanted to, or if someone forced them to.
So how does this digital magic actually happen? What is this secret handshake that lets two devices talk securely without anyone else being able to listen in? Well, it all kicks off with a concept called public key cryptography.
The very first time you use an app like Signal or WhatsApp, your device, quietly in the background, generates a unique, mathematically linked pair of keys. These keys are just for you. One of them is your public key, and the other is your private key. Think of them as two perfect halves of a whole.
Okay, first, you've got the public key. The best way to think of this is like an open padlock. You can make as many copies as you want and give them to anyone in the world. And anyone can use your public key to snap that padlock shut on a message, locking it up tight. But here's the trick. Once that padlock is snapped shut, only one thing in the entire universe can open it: your private key. This key never, ever leaves your device. It's your secret. So people can use your public key to send you locked messages, but only you, with your private key, can ever open them.
Now, this public-private key system is incredibly secure, but it does have one little drawback. It's kind of slow. It takes a lot of computing power to do its thing. So for a fast back-and-forth chat, using it for every single message would just be clunky and inefficient. So modern systems add another really clever layer.
And the solution is to add another layer, the session key. Here's how it works. Your device and the other person's device use that slow but super secure public key method just once, right at the start, to agree on a brand new temporary key. Then, they use that much faster single-use session key to encrypt the actual conversation. It's like using a master key to securely deliver a much faster everyday key.
And this is exactly how the messaging companies operate. They're just the delivery service. They can see the encrypted data, that locked safe, and they know where it's going, but the contents inside, completely inaccessible to them. They're just routing information that they can't possibly understand.
But what if something goes wrong? I mean, what if somehow one of those keys gets stolen in the future? Well, modern encryption has this incredible feature designed to protect you even in that worst-case scenario. It's an approach that basically bulletproofs your past conversations.
This feature is called forward secrecy, and its whole job is to make sure that even if some criminal manages to steal your main private key today, they still can't go back and decrypt all the messages you sent yesterday or last week or even last year.
The way it does this is, well, it's elegantly simple. Instead of using just one session key for the whole chat, the system generates a brand new one constantly, sometimes for every single message you send.
So if one key gets compromised, it's like a single broken link in a massive chain. It doesn't break the whole thing. It protects the integrity of your entire history.
Okay, so we've gone pretty deep into the mechanics of this, but let's zoom out. Why is this complex dance of keys and algorithms so fundamentally important? I mean, what is the real-world impact of having this tech at our fingertips?
First, it's really important to understand its limits. End-to-end encryption is fantastic at protecting the content of your message, the words and the photos, but it doesn't always hide the metadata. Things like who you're talking to and when you're talking to them, that can still be visible. The letter is secret, but the address on the envelope is not.
This level of security is absolutely essential for so many people. And we're not just talking about spies here. For a journalist, it's the digital shield that protects a vulnerable source. For a business, it's the lock on the vault of priceless trade secrets. For an activist, it can be a lifeline for organizing safely under an oppressive regime. And for all of us, it's the simple right to a private conversation.
Ultimately, end-to-end encryption really represents a fundamental shift in who or what we trust. We're moving from a model of trusting a company, a fallible human organization to protect our data, to a model where we just trust the objective, verifiable proofs of mathematics.
This mathematical trust is really the bedrock of our digital privacy. But technology never stands still. The tools that are used to protect us are constantly evolving, and, well, so are the tools that could be used to break them. So what does the future hold?
This is the question that keeps cryptographers up at night. As new technologies like quantum computing start to emerge, they pose a potential threat to the very mathematical assumptions that today's encryption is built on. The race is already on to create new, quantum-resistant algorithms to stay one step ahead.
And the stakes, they could not be higher. If the encryption we all rely on were to fail, the result would be catastrophic. It's not just about embarrassing messages being leaked, it's about the entire foundation of digital trust just crumbling, leaving every single one of us vulnerable.
In the end, this all comes back to a simple but really powerful idea. Privacy isn't about having something to hide. It's about having the fundamental right to control your own information, to decide who gets to see your thoughts, your conversations, and your life. And in our digital world, end-to-end encryption is one of the most important tools we have to protect that control.